Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, helping you learn wherever you go. I'm your host, Zach Memis, as we continue on with CompTIA Net Plus, and this is Network Service Functions. Great title for an episode. There should be some DNS in our future, I think, and Wes Bryant is here to help us out with all the information we need. Wes, good to see you.
Absolutely. It's great to be here, Zach. That's right. When they talk about network service functions, well, we technically got a lot of network services, but Zach already kind of let the cat out of the bag because there are two services that we need to worry about, and two services really that make up really important protocols. It's what allows us to either obtain IP addresses or to find computers out there, whether in our local networks across the internet. And they really are, when it comes to network services, two services that you really should know. Not only from a certification exam standpoint, obviously that's one of the reasons you want to know it, because you might be going into the Network Plus exam, and boy, wouldn't it be nice to just have these questions, or answers ready to go when they ask you scenarios. But even more so, because they're so important to your networking career, here at the Network Plus level, it's good to get a solid foundation, because you're going to be dealing with these almost sometimes on a daily basis, and they really form a lot of the major foundation communications that we have on the network as in general.
So Wes, could you tell us a little bit about the DNS service?
Yeah, Zach, great question. When we talk about the DNS service in general, right, what is it responsible for? I want you to think about how we talked about how routers communicate with other computers across the internet. Because essentially when you visit a website, you're asking a server for a web page, like we've talked about those protocols. So I have to know where to find that web server. Well, remember that when we talked about routers, like for instance in our OSI models, we said that the routers allow us to communicate via IP address, right? They look at routing tables, they look at the network, and they break down the network ID to try to find out where the network is, and if not, they pass it on based on the destination IP address, right? So in our layer 3 data packet, right, we have a destination IP address and a source IP address, and that's how the routers make their decisions, right? What we don't have are things like names, right? And if you think about it, domain name system, there has to be names involved because it's right there in the name, right? That's good for routers. That's great for computers, right? But it's not so good for us humans, right? I don't know about you, Zach, but I can't remember yesterday. Sometimes I wouldn't even remember my head if it wasn't attached to the net, right? So I want you to think about every website that you were going to visit out there. Do you know its IP address? Did you wake up when you went to Facebook this morning, maybe on your computer, and type the IP address of one of the Facebook servers? One of the Google servers? Did you go out there to Microsoft's website? Those of you that are maybe studying some Microsoft exams, and when you went up to TechNet, did you type in the web browser the IP address of the TechNet web server? No, you didn't, right? You typed a name. And a lot of times what we do is we type a name in a search engine. That's why I always say search engines first, right? But still, when you go to a search engine, you're going to a server and you're saying, I need to find something. And you type in and you interact with that search engine. But your computer found it on IP address, but when you typed it in by name, right? www.google.com, or if you're using Microsoft, www.bing.com, right? Those are names. They're not IP addresses. So if computers use IP addresses and it's easier for us to remember names, then how is that working in the background where I type a name and in the background it connects via an IP address? Magic. Not really. That's where the DNS service comes in. See, the DNS service is responsible that when my computer and the programs, or the applications, if you will, need to communicate across the network, right? They need to communicate via IP address, but when my computer doesn't know what the IP address is and all I have is a name, we go through a process using that DNS service. And that DNS service, with some components that we're going to show you, is going to go out there, search some databases, take that name, associate it with an IP address, and return back to your computer the actual IP address so that you can connect. And making it easier for us humans, we can remember names, which can be a lot more user-friendly, than a 4-octet IP address, or even more so an 8-octet IPv, or an 8-block IPv6 address, right? And that's the beauty of domain name system. Domain name system says when I type in something like www.google.com, HTTP, or www.itpro.tv, right? www.practice-labs.com. And it associates, goes out there, goes through the process, takes that IP address, maps it to it, returns the answer back to my computer. My computer says, oh, now I can connect. I didn't know what this name is, but now I have an IP address and I can get there. All right? But it is a hierarchy. DNS works through this hierarchy, and we have to know a little bit about the hierarchy. So let's go ahead and take a look at the DNS hierarchy. And to understand that hierarchy, you got to kind of understand the makeup, the DNA, if you will, of the name. All right, the name that we resolve is what's known as a fully qualified domain name, right? DNS, domain name system, works on fully qualified domain names. So what is a fully qualified domain name? All right, well, I've got an example of one right here. They're called FQDNs for short, but let's go ahead and define the acronym. You ladies and gentlemen have enough acronyms out there under your belt. I'll throw another one here at you.
FYI.
That's right. So when we talk about fully qualified domain names, that consists of what's known as a host name. It's a single label name, all right? And it sometimes in the Microsoft world, they call it a computer name as well, all right? As well as a domain name. See, a host name, like let's say, for instance, Server01. Let's say its computer name, its host name is SRV01. Well, when we attach that to the end of a domain name, like demo.itpro.tv, the whole thing together becomes what's known as the fully qualified domain name. So remember that is host name plus domain name equals FQDN. Now that sounds like a lot of algebra. When you start putting letters in math, I mean, I'm out. All right? But it is important to understand this name and how the resolution process works. We call it resolving the name, resolving the name. All right? Because, well, here in the States, we read what? Left to right. Now, I know that we've got viewers all around the world, right? And some languages, obviously, don't read that way. They read right to left, right? But when we're reading here in the States, right, we read left to right. And you would think that we would start on this side of the tracks to resolve a name. But DNS doesn't work that way. DNS actually works from the right and resolves back to the left. See, a hierarchical namespace is one that's broken up into different levels. And the levels are distinguished, if you will, by the little punctuation mark, the dot, as we call it. Period, if you will, but dot. All right? Now, I want you to notice something. You might look at this fully qualified domain name and say it's fully qualified to be wrong. Why? Notice there's an extra dot at the end. There's a dot just past TV. All right? What is that? Well, that's what's known as root. All right? We don't technically type in the dot. When I type www.google.com, I could technically put a dot after that. Our web browsers do that in the background for us. Why? Because the dot is actually the highest part of the DNS hierarchy. It's called root. Root hint, if you will. All right? And then from right to left, we have what's known as a top-level domain. Then the second portion of this is going to be what's known as a second-level domain. And you can have third-level domains. And then finally, after, and in this case, this whole portion makes up the domain name, we have the computer name. And when I need to resolve, or my computer needs to resolve a name, it needs to go through this process. Well, I don't know where srv01.demo.itpro.tv exists. So what I have to do is I have to talk to the first part of the hierarchy. And that's why it's important to understand a fully qualified domain name. Now, I put .tv in here. I could just as easy put something like, I don't know, .com, right? .tv is another one. But you guys would probably recognize something like .com, right? More than you do .tv. And I'll show you why here in a second. But understand .tv, is a fully qualified domain name. And when we look at the hierarchy starts with just that dot that you don't typically see, that we typically don't put in our web browsers, but the web browsers finish it in the background for us. All right? And the root server, it's responsible for what's known as top-level domains. See, the root, it doesn't do name resolution. It says, it looks at the request and says, oh, okay, I don't know who this, and I'll tell you what, I'm going to use a name that you guys are familiar with, right? So we'll do something like this. We'll do www.google.com, all right? And again, remember, the dot, that last dot is implied, all right? So my DNS server that's going to respond and hopefully give me the IP address says, I don't know, I'm not responsible for Google's web server. I don't own Google's web server, but I'm going to go ask somebody that can help me. And the first thing it does is it asks the root server, dot, if you will. It says, do you know where www.google.com is? A root server says, well, I look at the request. I don't know who this www you speak of is, and I don't know who Google is, but I am responsible for .com. You can go talk to .com. And it returns .com's IP address to the DNS server. So what does the DNS server do? Well, the DNS server turns around and says, okay, I'll go talk to .com. And if we can look here again, so the next part of this would be, all right, let me go ahead and talk to .com. And .com, the question's asked. .com DNS server, do you know where www.google.com is? .com looks at its database and little file, text file, looks at its database and says, I don't know who this www is you speak of. That's completely foreign to me. But I'm in charge of Google. I know who Google is. That's a second level domain, and I'm the authority over Google's domain namespace, that part of the hierarchy. Here's the IP address to my DNS server. Here's the IP address of .com, or excuse me, Google's DNS server. Go talk to Google. And then my DNS server says, well, I don't know if it says thanks, but we'll say it's a nice server. It says thanks. I'll go talk to Google's DNS server. And at this point, when we talk to Google's DNS server, you ask Google's DNS server, do you know who www.google.com is? Google says, oh, yeah, I'm in charge of www. Here's the IP address. You can find it here. My DNS server does a couple of things. It caches that response. Remember I told you we go through this name resolution process, but there is a little caveat to it. Caches that response. And then it sends the response, the IP address, the name and the IP address back to my computer. My computer says, oh, now I got a name, I got an IP address, let's connect to the web page. The search engine opens up. It's name resolution. Now I want to just real quick mention that caveat that I keep kind of stalling on, because DNS, just like any other service, if I can cache the answer locally, once I've got the answer, in fact, my computer will do that. Once it's got the answer, and I type www.google.com to make it more efficient, why go? I already got my answer. Why do I need to go back to the DNS server? So your computer and the DNS server looks for the answer stored locally in RAM. So my computer, next time I go to Google, is going to say, oh, got it. It's right here. It's loaded in random access memory. I've already got the answer. It's in what's known as the local resolver cache. But let's say, for instance, I just turned my computer on. Well, it can also ask my ISP or my DNS server that I'm using, configured in the TCP/IP properties of the network adapter, and my DNS server could say, oh yeah, somebody asked me for this earlier, and I went through that whole hierarchical process. Google returned me the IP address of www. Here's your answer. We get a faster name resolution. So I do want you to know about the local resolver caches. That is important. All right. And we've got this hierarchy. Right? So if we continue on down the path that leads to hierarchy, we also have second level domains that I mentioned. And to kind of give you an idea, right, we can see that we've got Microsoft, Google, and Facebook. Every one of you, or most of you, are probably familiar with it, right? .com, right? Microsoft.com, Google.com, Facebook.com. And you guys can go, if you want to take the time and you want to look these up, by all means, please do. .net, Verizon.net, Speedtest.net, Earthlink.net, right? All these second level domains are under .net, that is the authority over those domain namespaces. So if I'm looking for Verizon, my computer's, I type in my computer's web browser, www.verizon.net, well, guess what? The name resolution process is going to go just the same. My ISP, or I keep saying ISP, and you'll see why I'm getting there in a second. My DNS server that I'm using is going to say, well, let me go talk to root, if I don't have it locally. Let me go talk to root. Root's going to point me over to net because it's in charge of that namespace. .net's going to say, no, I don't know who www is, but I do know who Verizon is. I'm in charge of that namespace. So why don't you go ahead and talk to Verizon? And the same thing with .org, right? Another top-level domain, right? WordPress.org, probably heard of it before. I'm sure you've probably heard of Wikipedia, .org, right? .org, organizational top-level domain, right? It is responsible for Wikipedia's namespace. Same thing with Mozilla, those of you out there that like Firefox. .edu, right? Educational or academics, right? Harvard, MIT, Berkeley, they all use the .edu. We've got .mil for the military, right? The branches of our armed forces here in the United States. .mil's military top-level domain. .gov. There's some that we haven't put in here. .gov, government, right? Now let's go ahead and let's kind of focus in on some of the second-level domains and kind of understand what's going on here. All right. When we look at some of the second-level domains, let's say that we were going to Microsoft. Right? Maybe Microsoft has got a SMTP server that we've got to send some email. I doubt it, but maybe they do, right? Well, I need to know, my email system needs to know where's the IP address of smtp.microsoft.com. I'm making the host names up. I don't know. You shouldn't know that. You should be inside of somebody's network, right? I don't have to know that, right? So my computer says, oh, actually, it could even be the email server says, hey, let me go rely on DNS. DNS, go through this process, and process starts over again. Dot says, go talk to .com. .com says, I don't know who SMTP is, but I do know who Microsoft is. You go talk to Microsoft, and then Microsoft's DNS server looks at its database and says, yeah, I know who the host SMTP is. And you can find it at this IP address. And that answer comes back to my computer or my email client, and the communication happens. All based on the name resolution process. All right. So that is a little bit about our hierarchical fashion, right? It's what they call a logical tree topology, right? Maybe we've talked about topologies in other episodes, and one of the things that they don't call out anymore is a tree topology, right? And that's where you have a root node, and then you have second level nodes, third level, fourth level nodes, right? Well, they kind of took that one out of there because it's not really, I don't know how common it is, but logically, DNS is a tree topology. It's a hierarchical fashion that starts at the root and branches down to lower level domains leading back to the hosts. And it is important. Now, I will tell you that when it comes to the hierarchy, know it. Know what a top level domain is. Know what the root is. Know what a fully qualified domain name is. All right. And when we talk about a fully qualified domain name, I want you to remember, all right, like on my computer here, if they show you a name and it looks like this, that is not a fully qualified domain name, right? That's just the host name. That isn't hierarchical in fashion because how many computers out of the millions or billions of computers that are out there across the internet, do you think there's one anywhere where we might have SRV01 and another SRV01? How many Johns do you think? Or John Smiths? How many how many people out there do you think have the name Bill or Bob or Sally or Sarah? Right? It's not unique enough. And sometimes even the last name isn't unique enough because you can have multiples of that. So we use the hierarchical nature of DNS because then it becomes a unique naming convention across the entirety of the world. All right. Now, you might still say, well, SRV01, there's one in company A and company B. That's right. But with the unique domain names, company1.com, company2.com, SRV01 in each domain now become unique because the fully qualified domain name in its hierarchical fashion means those two names are not the same, even if the host name is. Just like if they say, is this an example of a fully qualified domain name? No, it's not. It's a host name. And you have to have both, right? You can't have one without the other. And that is a little bit about your DNS hierarchy.
Fantastic. And Wes, wonderful. I understand, and I'm always happy when I understand. I wanted to ask about this, though. DNS servers, where are they located? You mentioned internal, external. Where are they at?
They are located everywhere. All right?
I knew that was coming.
Everywhere. But which one you use is really contingent on how the properties of your network adapter are set up. Mm-hmm. All right? So let me show you what I mean here. All right? So I've got internal versus external. All right. Now, when we talk about internal DNS servers, all right, I want you to know that an internal DNS server is one that's within your local area network. That's an internal DNS server. It's internal to your network. All right. So, for instance, if I have a domain controller within my network that relies, domain controllers, especially Active Directory, rely heavily on DNS to find services, objects, and map them to their IP addresses within a Windows domain. Well, I'm also going to need a DNS server to allow that directory to function. So I can have an internal DNS server that says when this computer, let's say, just take any one of these computers, needs to find another computer within this network via its fully qualified domain name, I send it to the internal DNS server. All right. Now, the internal DNS server, we got to be careful because the internal DNS server isn't the authority of anything that's out there across the internet. All right. We have the Internet Corporation for Assigned Names and Numbers, ICANN, right? And then they're responsible for things like the unique names out there, INA, if you will, the Internet Assigned Numbers Authority, all of these different standards bodies. And the standards bodies are the ones that oversee public DNS servers. Now, a public DNS server is also an external DNS server. Okay, so I want to kind of clarify, understand that because you'll hear different terms. CompTIA does a very good job keeping it vendor neutral, right? But you could hear internal and external, you could hear private and public, right? And let me tell you why. Because if Zach in no way knows nothing, doesn't know anything about my internal infrastructure within my network, his DNS server is not going to know anything about the computers that are in my network, just like my DNS server is not going to know how to resolve the names that are to IP addresses of the computers that are within his network. That's why they're called private. They're internal servers. They resolve internal addresses. All right. External DNS servers, what do? So if we could take a look here, you could have, and this is why I kept saying ISP. All right. When I need to resolve a name out there across the internet, I'm going to send that DNS request to an external server. And what are we going to do? In this case, probably be your internet service provider. And your internet service provider is going to go through that process for you. Somebody else is going to do the heavy lifting, right, of the public or external DNS servers, right? Now, you also have things like, well, Google. Now, be careful with Google because Google has their own DNS servers, right? So understand that, yes, they're a top level or a second level domain, but they also have public DNS servers, external DNS servers that you can send information and get or requests to and get responses back. IP addresses just happen to be 8.8.8, 8.8.8.8, and 8.8.4.4. All right. Level 3. Level 3 is one of what's known as an internet backbone provider. All right. They have external DNS servers, and by the way, they also control some of the root hint servers as well, right? So these big guys, all right? And that's the difference. Now, I don't want you to think when I say, and let me make a clarifying statement so there's no confusion here. Yes, my internal DNS server, it can resolve names that are out there across the internet. But what it's doing is what's known as a forward, right? My local DNS server, my internal DNS server can resolve those names, those fully qualified domain names to IP addresses on my local network. And then what we can do is just like your mail forwarder, right? I can forward a request for an external name resolution lookup. Maybe I am looking for Microsoft, right? www.microsoft.com. Well, if we can take a look here at my computer, we can ask that internal DNS server, hey, do you know where www.microsoft.com is? And if a lot of times what the admins will do is configure a forwarder that says, no, I'm not the authority. I don't have that in my database. But I tell you what. Let me go ahead and I'll forward that out the router, and I'll forward that question over to the ISP's DNS server. Because guess what? The ISP's DNS server is going to go through the process of the external name resolution part of that, going to return an answer through that process back to my internal DNS server, and guess what my internal DNS server is going to do? It's going to cache it. So the next time I'm looking for Microsoft's website, www.microsoft.com, now my internal DNS server says, let me look at my local resolver cache. Okay, it's there. Here's your answer. So part of the name resolution process, do I already have the answer? No, I don't. Or I do, and I return it, and you don't have to go through the name resolution process. Let's say, no, I don't. All right. Am I the authority? Second step. Am I the authority? My internal DNS server is not the authority over Microsoft's DNS servers. No, it's not. All right, so I need to talk to somebody. Do I have a forwarder? If I have a forwarder, just send it out to whatever that DNS server is. If not, let me look at the IP addresses of the root hint server. Oh, okay, I've got the IP addresses of the root hint server. Go talk to root. And then that process goes. All right? So do keep that in mind. All right? Now, you also have things like your third-party DNS servers and cloud-hosted servers. All right? So, for instance, you can pay somebody like GoDaddy. GoDaddy is a domain registrar, right? If I want to have a domain name out there, right, and I want it to be publicly accessible, I got to go to a domain registrar, and I got to register with them, and they're going to be licensed, bonded, insured, right, just in case there's any malicious activity. You'll still be held accountable, but anytime it's a publicly resolvable name, there has to be accountability. So I can go to somebody like GoDaddy.com, and I could say, I want to bring up my domain, and I want you to host the DNS records, third party, right? Now, they are providing the name resolution worldwide across the worldwide DNS system for my domain. And I don't have to manage the DNS servers. So that, for small businesses, works. The second one that I mentioned is cloud hosted. And that's what we use here, by the way. We don't have internal DNS servers, right? We send ours either up to AWS or I believe it's AWS, but it might be Azure, or it could be both. I know that some of the people that are behind designing our network here don't put all their eggs in one basket, and they might use 2 cloud providers just to provide redundancy, but it's very hard to get more redundant than the AWS infrastructure. They've got the biggest infrastructure in the world. But either way, Amazon's managing it, right? And they're giving us the virtual DNS service, and they provide it for a service, kind of like GoDaddy does, all right? So that's the difference between the third party and the cloud hosted.
Now, Wes, you were talking about names, like Mezak US names. Well, can you tell us a little bit more? What do you mean by names? Name management.
That's right. And so names are an interesting thing. But you know what, Zach? I think with such a big topic like that, we might have to go into a part 2. Cliffhanger.
Oh, boy. Network Service Functions Part 2 coming your way. This has been Network Service Functions Part 1 inside the CompTIA Net Plus series. Wes, wonderful job as always. And you want to make sure you watch every single episode in the CompTIA Net Plus series. And check out all the other videos we have in our course library. They're all designed to do one thing, help you go further. And tell everybody you know about IT Pro TV. They'll be glad you did. Thanks for watching. I'm Zach Memis.
And I'm Wes Bryan.
And we will see you soon.
Thank you for watching IT Pro TV.